They're colossal, they're complex, they're some of the most impressive feats of engineering humanity has ever achieved. They brave relentless storms, tap into the Earth's resources, and operate like small cities in the middle of the ocean. This is GLOBALINE, and today we're diving deep into the insane engineering behind offshore oil platforms. For decades, the world's oil needs were primarily met by land-based wells. But as the demand for energy surged, particularly with the rise of the automobile and industrial expansion, we began to look beyond the coastlines. The very first offshore oil platform was built in 1897 in California, a simple structure extending just 300 feet into the sea. It was a humble beginning, but it signaled a monumental shift in how we access our planet's resources. The mid-20th century, it became clear that the future of oil production was going to be offshore. The world's demand for oil was increasing exponentially, and the onshore reserves were not sufficient to meet that demand. And so began the age of the offshore giants. Platforms that stretch for miles, reaching deep into the ocean and capable of extracting millions of barrels of oil. But these engineering marvels didn't come easy. They faced some of the most extreme challenges on the planet. The ocean is an incredibly unforgiving environment. These platforms face constant assault from some of the most extreme weather conditions on Earth. Massive waves, sometimes reaching over 100 feet, hurricane-force winds exceeding 150 miles per hour. It's a relentless battle just to stay afloat. The immense pressure of the water at the depths where these platforms operate is another massive challenge. At depths of 3,000 feet, the pressure can reach over 1,300 psi. That is enough to crush a submarine. And the corrosive nature of salt water means every component must be incredibly durable and resistant to degradation. To overcome these obstacles, engineers have developed a range of incredible solutions. From fixed platforms anchored to the seabed, like the Bullwinkle platform which stood on 12,500 feet tall legs, to floating giants like the Perdido platform in the Gulf of Mexico, which operates in water depths of over 8,000 feet. Each design is a testament to human ingenuity. Each component is precision engineered to withstand incredible stress. We're talking massive legs that weigh thousands of tons, made of high-strength steel that has been tested to withstand pressures of up to 100,000 psi. Tension systems that keep platforms stable even in the roughest seas, and cranes capable of lifting immense loads of up to 12,000 tons. It's a truly astonishing scale of engineering. But simply staying afloat is only half the battle. These platforms are designed to extract oil from deep beneath the ocean floor, an incredibly complex and challenging process in itself. On average, a single platform can have over 20 wells drilled into the seabed. Powerful drilling rigs bore through layers of rock and sediment to reach oil deposits miles below the seabed. Some of these wells can reach depths of over 30,000 feet and are drilled with incredible precision. The process involves highly specialized equipment and precise control to avoid damaging the well or causing environmental disasters. The average recovery rate of oil in these reservoirs is about 40%. Once the oil is extracted, it needs to be processed, separating it from water, gas, and other impurities. It is then stored and eventually transported to shore via pipelines or tankers. All of this occurs on the platform itself, which is essentially a self-contained industrial complex. This is not just a massive structure, it's a fully functional industrial city in the middle of the ocean, with living quarters for hundreds of workers, processing facilities, and advanced control systems. Every component is meticulously designed and interconnected to ensure efficient and safe oil production. The journey of an offshore oil platform begins long before it reaches its operational location. It starts with construction, often in specialized fabrication yards around the world. These yards are massive industrial complexes capable of assembling gigantic steel structures. The fabrication process involves thousands of skilled workers using advanced technologies to weld and assemble the platform's components. For a large platform, this can take 3 to 5 years, and 3,000 to 5,000 workers to complete the job. The amount of steel used is staggering, with some platforms requiring over 100,000 tons of steel. The construction of an offshore platform is a truly global endeavor. The supply chain is vast and complex, involving thousands of companies around the world, from steel mills in South Korea and China to electronics manufacturers in Japan and Germany. The fabrication yard is just the final assembly point. Components are manufactured in hundreds of different factories, then transported by specialized ships, trucks, and trains to the construction site. This global network involves tens of thousands of workers across different countries, each contributing to the creation of these massive structures. Some parts can be thousands of miles apart, but they all contribute to a single goal. Once the platform sections are completed, they must be transported to their final location, often thousands of miles away. Heavy lift vessels, some of the largest ships ever built, are used to transport these massive structures. The journey can take weeks or even months, depending on the distance and sea conditions. The platform is towed by tugboats at a very slow speed, sometimes at only 5 or 6 knots. But the sheer scale of these operations is awe-inspiring. For example, transporting a platform from South Korea to the Gulf of Mexico can take up to 3 months and cost millions of dollars in fuel and logistics. The installation process is another massive undertaking. Once the platform reaches its location, it must be precisely positioned over the designated site. This is often done using GPS technology and advanced positioning systems. The anchoring process is also a complex task, with different methods used depending on the platform type and seabed conditions. For fixed platforms, massive pilings are driven deep into the seabed, while floating platforms use tension legs or dynamic positioning systems to stay in place. The costs of installation can range from $50 to $150 million, depending on the complexity of the operations, the depth of the water, and the type of platform. The costs associated with an offshore platform extend far beyond its construction and installation. Operational costs, including maintenance, staffing, and energy consumption, can range from $20 to $50 million per year. Over a typical 25 to 30-year lifespan, a platform can produce billions of dollars worth of oil, and it is estimated that the total lifetime costs, including decommission, can reach up to $5 to $10 billion. These platforms are not just isolated structures. They are the center of a global industry that impacts millions of people and trillions of dollars in trade. Life on an offshore oil platform is a world apart, a unique blend of industrial rigor and human resilience. Workers typically live on these structures for 14 to 28 days at a time, away from their families and the comforts of home. The living quarters, while functional, are designed to provide a sense of comfort, with bunk rooms that usually accommodate 2 to 4 people. They are not luxury suites, but they offer a place to rest and recharge. Daily routines are highly structured, with work shifts often lasting 12 hours. In their downtime, they enjoy facilities like the mess hall, where they consume, on average, over 5,000 calories per day to keep their energy levels up. The recreation area offers a place for some relaxation, with TVs, games, and books. For health and well-being, most platforms have a gym or fitness area, allowing workers to maintain their physical health. And of course, medical bays are essential, staffed with trained medical personnel to handle any injuries or illnesses. The work on an offshore platform is demanding and requires constant vigilance. The control room is the nerve center of the operation, with workers monitoring complex systems and ensuring everything runs smoothly. Communication is critical, with workers using radio and satellite phones to stay in touch with other parts of the platform and the outside world. Maintenance and repairs are an ongoing process, with skilled workers using specialized tools to keep the platform running efficiently. Safety is always a top priority, with regular safety briefings and drills to prepare workers for any potential hazards. Despite all these responsibilities, it's a job that fosters a unique sense of pride. When the workers look out at the ocean, they know that what they are doing is a great and important job. Life on a platform is not without its challenges. The work can be physically demanding, and the environment can be unpredictable. It's not uncommon for workers to face unexpected issues, from equipment malfunctions to weather-related problems. But they rely on each other to overcome these challenges. Teamwork is essential, with workers helping each other through difficult tasks and resolving technical issues. Safety drills are a regular part of life on a platform, with workers practicing emergency procedures to ensure everyone is prepared for potential hazards. They are constantly training to improve their skills and to stay up to date with the technology. Despite the challenges, there is a strong sense of camaraderie on these platforms. After a long day of work, workers will often gather in the recreation areas to play cards, watch movies, or even participate in talent shows. It is a very tight-knit community. Let's look at the numbers behind the human element on an offshore platform. On average, a platform houses between 100 and 300 workers, depending on its size and complexity. These workers operate on a rotation schedule, typically working 12-hour shifts for 14 to 28 days before returning home for a similar period. They consume an average of 5,000 calories per day, including over 2,000 eggs on average per year on one platform, and a lot of chicken and meat. Safety is paramount, with workers receiving an average of 100 hours of safety training per year. Medical facilities are a key component of the platform, typically staffed with 2 to 3 medical personnel, including nurses and paramedics. These platforms are not only places of work, but also have internet access, with average speeds of 20 megabits per second, allowing workers to stay in touch with their families and the outside world. In their time off, most workers will spend 5 hours online using the internet. They are also a place of community with over 5,000 books on a single platform. Innovation is driving the future of offshore oil platforms. Remotely operated vehicles, or ROVs, are now a standard part of platform operations, allowing for detailed inspections and repairs in deep and dangerous environments. These ROVs can operate at depths of over 10,000 feet, with the camera providing high-definition footage of the structures and the seafloor. 3D printing is also changing how platforms are maintained, with components being printed on demand, reducing downtime and waste. Advanced sensors monitor everything from structural integrity to weather conditions in real time, feeding data to control systems for immediate actions. Drones are used for routine inspections, reaching areas that were previously difficult to access, reducing safety risks, and automated drilling systems are improving efficiency and precision, reducing the potential for human error. These advancements are not just about improving output, but are also about increasing safety and reducing environmental impacts. Looking ahead, offshore platforms are poised to become more sustainable, efficient, and integrated with the marine environment. We envision platforms that are powered by renewable energy with minimal environmental impact. They will not only be energy producers, but also hubs for various ocean activities, like aquaculture and scientific research. Imagine a world where platforms work in harmony with other ocean infrastructure, creating a sustainable ecosystem. Platforms that are almost self-sufficient with the latest technology, with minimal human presence, but still able to extract the necessary energy resources. This future is not just a dream, it is an achievable reality, driven by human ingenuity and our commitment to a sustainable future. The story of offshore oil platforms is a testament to human ambition and our ability to conquer seemingly insurmountable challenges. These structures, built to withstand the harshest conditions, are incredible feats of engineering, working cities, and symbols of human resilience. They are not just about oil, they are about our capacity to innovate, to explore, and to build a more sustainable future. This has been a journey into the heart of offshore engineering, a look at the human element and a glimpse into the future. This has been GLOBALINE. If you were inspired by this look into the world of offshore engineering, we encourage you to like this video, subscribe to our channel for more content, and leave your thoughts in the comments below. We are a community of curious minds and we want to hear what you have to say. Join us as we continue to explore the world's most incredible engineering feats.